factors affecting the enzyme catalyzed reaction. So various factors SAR must have told, that is effect of substrate concentration, effect of enzyme concentration, effect of product concentration, all these things must have been discussed already. So just see this graph. This graph shows the x-axis you have the concentration of substrate, whereas on y-axis you have velocity. So when you plot a graph between substrate concentration and initial velocity, you will get this graph. So this graph can show you the effect of substrate concentration on the velocity of the reaction. So this graph represents the relation between the substrate concentration and change in the velocity. Now you can see here, this is a zero concentration of the substrate, and as you move towards right hand side from the intersection of the graph towards right hand side, if you are moving, the concentration of the substrate is increasing. Let's say here the concentration of substrate is 0, it is 10, 20, 30, 40, 50 and so on. When you move on the x-axis towards right hand side, the concentration of the substrate is increased. Similarly, from the interception, you can see the y-axis representing the velocity. So here it is 0, here it is 10, 20, 30, 40, 50 and so on. This is how the measurements have been taken. Now the graph is actually it is a parabolic graph. Now you can see here, in the beginning where the concentration of the substrate is less, the velocity of the reaction is also 0. As the concentration of the substrate is increasing, there is increase in the velocity of the reaction. From the graph you can understand that as the concentration of the substrate is increased, the velocity of the reaction is also increased, and it reaches to a maximum called Vmax. It reaches to a maximum called Vmax. So Vmax means it is the maximum velocity for that enzyme catalyzed reaction. So to understand the relation between the velocity and the substrate concentration, there is a constant proposed by a scientist called Michael and Menten. So they have given a constant called Km. Km means Michael's Menten constant. Michael's Menten constant. So in this graph you can see Km. So Km is here, and respective value that is present on y-axis is called half the Vmax. Respective value that is present on the y-axis with respect to Km is called half the Vmax. So Km, it is the substrate concentration at which the enzyme has half the maximal velocity. So Km means it is the substrate concentration at which the enzyme has half the maximal velocity, or maximal velocity is half of the velocity, that is called Vmax by 2. I will tell you in detail. So this is a graph showing the relation between velocity of the reaction and concentration of the substrate. So to explain this relation between the substrate concentration and velocity of the reaction, Michael's Menten equation was proposed by the scientist Michaels and Menten. So they have derived an equation. See here, V0 or V0 means is a initial velocity is equal to Vmax into substrate concentration divided by Km plus substrate concentration. So this is a formula used to calculate the velocity of the reaction. So to identify the V0, we need to know what is Vmax, what is substrate concentration, then what is Km, and again of course substrate concentration. So if you know substrate concentration and Vmax, V0 Km value also, V0 can be calculated. So here V0 is initial velocity, Vmax is called maximum velocity of the reaction, S which is mentioned in square brackets is called concentration of the substrates, and Km is called Michael's constant. Km is called as Michael's-Menten constant or Michael's constant. Let us see what is the significance of Km. So let us try to understand what is the significance of Km. So Km indicates the affinity of enzyme towards the substrate. Km indicates the affinity of enzyme towards the substrate. Smaller the Km, larger the affinity, and larger the Km, smaller the affinity. Affinity we have already discussed. Again I will tell you, but again I am repeating the same slide. See here, Km means it is a Michael's-Menten constant. It indicates the affinity of enzyme towards the substrate. It indicates the affinity of enzyme towards the substrate. Smaller the Km, larger the affinity, and larger the Km, smaller the affinity. So from these sentences you can understand that Km and substrate concentration are inversely related. They are inversely proportional to each other. That is why if one increases, the other decreases, and other increases, the next one decreases. So this is called inverse relation. That is why I have mentioned here, smaller the Km value, larger is the affinity, and larger the Km value, smaller is the affinity. So affinity means, it is like, affinity means attraction, or what you say, you can say love also. So the affinity means love towards substrate or love towards enzyme. So the substrate and enzyme, how strongly they are having affection is called affinity. So if larger the Km value, smaller is the affinity. Means if Km value is very high, affinity is very less. But if Km value is very small, affinity is very strong. That is what you need to understand, and that is the significance of Km. So we have already discussed about the factors affecting enzyme activity. I am just listing out the different factors affecting the enzyme activity.